Hi everyone, today we're going to talk about the Lewis structures, how to draw the Lewis structures for different formulas. So there's a nice simple 6 steps to do that. First one is the skeleton, second one is count valence electrons, and third one single bonds, 4 octets with lone pairs, and 5 check valence electrons and double triple bonds. So we get to the problem straight away. So first one, nitric oxide. So as seen on over here, nitric oxide has ingredients of nitrogen and oxygen. So big N, big O. So this is the skeleton. So then count valence electrons. On the side you write valence electrons for each element. So nitrogen group 5 provide 5 valence electrons, and oxygen group 6 provides 6 valence electrons, total 11. Then single bonds, put a single bond in between these two elements. Then octets is lone pair, so we have to complete the octets. Therefore this bond has 2 electrons, so considering that, therefore we have 2, 4, 6, 8. And same thing for the nitrogen, 2, 4, 6, 8. So now we calculate again how many valence electrons altogether. So now we count like this: 2, 4, 6, 8, 10, 12, 14. So there are 14 now. So now there are 3 more. So therefore we can add, for every 2 valence electron, we can add 1 double bond. So what we can do, we put a 1 double bond, 1 bond more, and then erase 2 from each side. That's responsible for 1 bond. So now we're gonna calculate again how many valence electrons. Therefore 2, 4, 6, 8, 10, 12. So now there are 12. Give me a second. Am I done wrong or not? 2, 4, 6, 8, 10, 12. Okay, so now we have 12 valence electrons, but originally we had 11. This one over 11, then not 12. So therefore 1 electron is excess here. Therefore we can remove 1 electron out of this configuration. So either we can remove from hydrogen, or we can remove from the oxygen. If you remove from the nitrogen, this we can consider this one, we can take away. So what we can do, we can erase this one. So this is the first representations. Other one from the oxygen. So what we can write, so same thing again, nitrogen going to be the same, nitrogen going to be the same, and double bond, and oxygen we're going to take 1 away. So it's got like this. So this is the second structure. So we can see now 2 structures, 2 favorable structures over here. So first one is like this, and second one is like this. So now we have to understand what is the most favorable. So to get the most favorable bond, what we can do, we can calculate formal charges for each one. So first reaction I label first, this one second. So considering the first one, how do you calculate the formal charges? We get nitrogen in the group 5, therefore 5, and 5 minus, so you can see on the previous lecture about formal charges. So 5, I tell you again. So nitrogen, concerning nitrogen on the group 5, therefore it provides 5 electrons, 5 valence electrons, and it has 3 valence electrons, lone pair electrons. So here you can see here 1, 2, 3 3 lone pair electrons. So therefore this lone pair electron 5 minus 3 minus bonds. How many bonds? How many bonds? So here see 1, 2 bonds. So we 5 minus 3 minus 2 equal 0. Therefore this nitrogen has 0 formal charge. And what about the oxygen? Oxygen group 6 minus lone pair electrons 2, 4 and minus double bond 2 bonds. So therefore 0 again. So therefore this oxygen also has 0 formal charge. Now move to the second one. Okay, second one. So nitrogen again on group 5 provide 5 valence electrons and it has 4 lone pair electrons, 4 minus 2 2 bonds. Therefore it is minus 1. Therefore there is a minus charge. And oxygen group 6 minus lone pair electrons 3 minus bond 2. So then it's become 1 plus 1. Therefore there is a plus. So in stability concern, any compound has 0 charge are more favorable. In the first one 0 charge, because if they have some molecular polarity, it more trend to reaction happen. But if there are no polarities, less polarity, it is very less reactive, mean more stable. Therefore the first one is got 0 potential, it is more favorable. If you got this one, it is less favorable because it got a positive and negative polarity. Okay, let's move into the other questions. This time pbrt. So we write pbrt like this: big P in the middle and BR. So that's the skeleton. Okay, so now count valence electrons. So phosphorus on group 5 provide 5, bromine group 7 there are 3 of them, 7 times 3 equal 21, altogether 26. Now single bonds, and now octet. So phosphorus 2, so you can see phosphorus 2, 4, 6. Therefore it need 2 more electrons. So we put here. So bromine, what happened? Bromine 2 here, 2 here, 2 here. Therefore we need to 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay. Now we count valence electron again. So how do we count? We count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So it is 26. So therefore it is complete, no remainder. Therefore this is the Lewis structure for pbr3. Let's move to the other one. This time N2H2. So big N, and H2. First thing, this is the skeleton. So now count the valence electrons. So now hydrogen group 1 provide 1 electron, there are 2 of them, therefore 2. Nitrogen group 5, 2 of them 10, therefore 12. So now single bonds. Now octet. Hydrogen is satisfied, it's okay. Nitrogen, so nitrogen you can see now here two bonds. One bond is 2 over here, 2 electrons and 2 electrons. It needs 6 more electrons to complete the octet. Therefore we put 4 like that. Same thing over here for this nitrogen. Okay, now we calculate again the whole valence electrons. Okay, whole electron, whole valence electrons. So therefore 2, so we calculate like this: 2, 4, 6, 8, 10, 12, 14. Okay, so this is coming 14. So 2 advance. Therefore we can put one bond. 2 electrons correspond to one bond. Therefore we put one more bond in between nitrogen and nitrogen. One bond, and then what happened? 2 electrons disappear like this. So now you can see each nitrogen has octet: 2, 4, 6, 8. 2, 4, 6, 8. Therefore this is the Lewis structure for N2H2. Okay, we move the other one. This time methanol. Methanol, how do you write methanol? Methanol, big HC, big C and H, 3 OH, OH. Before that, I think more better if we go this way. Okay, now what are the components or ingredients? We need carbon, 3 hydrogens, and give me a second. O and H. Okay, so this is the skeleton. So now 4 hydrogens give 4 electrons, 4 valence electrons. 1 carbon give 6 because this group, sorry, 1 carbon give 4 electrons. It is in the group 4 because it's in the group 4, therefore it gives 4 electrons. And oxygen in the group 6 electrons. So altogether 6, 4, 10 and 14. So now one single bond. So single bond, hydrogen is happy now. Okay, so now here, so octet for carbon 2, carbon, if you get like this, carbon 2, 4, 6, 8, satisfy. Oxygen 2, 4, therefore it need 4 more electrons. So we put 4, 1, 2, 3, 4. So now count valence electrons again, how many on there. Okay, therefore you can see 2, 4, 6, 8, 10, 12, 14. Therefore 14 over here. So remainder is 0. Therefore this is the Lewis structure for methanol. Now move to the other one. There's a one previously written down one over here. So see what we can do. Okay, so don't worry about this one here. Okay, what we can do, we do here. Don't worry about this part, it is wrong. So what we can do here, now first thing is skeleton, NO2. Then count valence electrons. So nitrogen give 5, oxygen give 12, so 17. Okay, so now single bonds. Now octet: 2, 4, 6, 8. 2, 4, 6, 2, 4, 6, 8. Okay, now count valence electrons. So valence electrons now counting: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 of them. 20 of them. So 20 of them. 20 of them, and therefore 3 to here. Therefore we can put one double bond here, one double bond, and 2 of them go away. Okay, so now concerning this oxygen: 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So now you can see there's a minus charge over here. So now we're going to calculate the formal charge for this all components to get the minus one. Okay, where the minus one belong to. So oxygen concern, formal charge, oxygen group 6 and 6 lone pair electrons and 1 bond. It is minus 1. Therefore minus charge over here. If you get this nitrogen in group 5 and lone pair electrons 2 and bonds 3 equals 0. So 0 formal charge. And if you get this oxygen over here, what happened? Oxygen group 6, lone pair electrons 4, 2 bonds equals 0. Therefore 0. So you can see there's a minus charge on this left hand side oxygen over here. This left hand oxygen, there's a minus that is belong to this minus over here. Okay, let's move to the another question. So C2H4. So what we can write? We can write a big C H4 H. So now count valence electron. Carbon group 4, 2 of them, 8. Hydrogen group 1, 4 of them. So together 12. Now single bonds. Now count octet. Okay, 2. So you can see 2, 4, 6. Therefore you need 2 more here. And also here 2, 4, 6. Need 2 more. Therefore 2 more. Oh, now count valence electrons again. Okay, so how do you count? Count one here: 2, 4, 6, 8, 10, 12, 14. 14 over here. So therefore 2 advance. For each 2 electrons we can put 1 bond. Therefore what we can do, we put 2 bonds and 1 bond, and this go away. So this is the, so now you can see carbon is satisfied. 2, 4, 6, 8. 2, 4, 6, 8. Therefore this is the Lewis structure for C2H4 or ethene. Okay, let's move to the other one. BSF. BSF. Therefore, boron is the most electropositive. It is on the middle, and S and F on the side. This is the skeleton. Now count valence electrons. Sulfur in group 6. Boron is group 3. Fluorine group 7. So altogether 16. So now single bonds. Now octet. Okay. So octet we count for the sulfur 2, 4, 6, 8. Fluorine 2, 4, 6, 8. Okay. And I do this one like a trial, and then if it's wrong I do other way. Okay, so what you can do is 2, 4, 2, 4, 6, 8. Just a second, I look at the reference. Okay, so what you can do, okay, boron doesn't count 8, therefore now we count valence electron again. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so what we can do here, we can put 2, 4. So now 2, now 2, 4, 6, 8, 10, 12, 14, 16, 18. So 18 of them here. So we delete and write 18. No, sorry for this. So it is 6 from the sulfur, 3 from the boron. That's 16. Now 2, 4, 6, 8, 10, 12, 14, 16, 18. Two things over here. Therefore, we can put one double bond here and take away 2 like this. So now 2, 4, 6, 2, 2, 4, 6, 8 and 2, 4, 6, 8. 2, 4, 6, 8. So this is the structure for BSF. So you can count 2, 4, 6, 8, 2, 4, 6, 8, 6, 8. Let's move to the other one. HBr. HBr. So this is a skeleton. Counts valence electron. Hydrogen give 1, boron gives 7, so 8. So single bonds, octet. Octet we count like this. This is 2. This is 2. One bond is 2 always. So 2, 4, 6, 8. Now total valence electrons 2, 4, 6, 8. 2, 4, 6, 8. So 8 here. So 0. So this is the Lewis structure for HBr. Okay, then we move to the question. C2H methanol. Okay, C2, C2, H, 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 can do like this. Okay, and then OH. Okay, we can put one more hydrogen. Okay, now the final thing. So we have to get a skeleton. So then valence electrons. Hydrogen, there are 5 hydrogens, point 6 hydrogens, 6. Carbon, 2 of them, 8. Oxygen, 6. So 20. So now single bonds. Single bonds. Okay? Single bonds and then octets. So this oxygen need 2, 2, 4, 6, 8. So now count the valence electrons. So we count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it is saying 20. Saying 20, therefore 0. So this is the Lewis structure. And N2F4. N2F4. N2, N, N, F4, F, 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 F. So now count valence electrons. Okay, nitrogen in the group 5, there are 2, 10 of them, 10 of the numbers. Fluorine in the group 7, there are 4 of them, that 28. Altogether 38. So now single bonds. Now octet. Okay, nitrogen 2, 2 here, should be 2 here. This one should be 2 here. So because this is 2, this is 4, this is 6, this is 8. 2, 4, 6, 8. So now we're going to do for the fluorine. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So now count the valence electrons again all together. So how do we count? We count like this: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. It is provide 38. Therefore 38. Therefore 0 balance. So this is the Lewis structure for N2F4 and SF6. Okay, SF6. So S in the middle. There are 6 F. So we can put F over here, F over here, F over here, F over here, and F and F. Okay. So now count valence. Sulfur given sulfur in the group 6, 6. Fluorine 7. There are 6. That's 42. So then 48. So now single bonds. Single bonds. Okay. Now octet. Octet. 2. So 2. Don't worry about sulfur. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6 8 2 4 6 8 2 4 6 8 2 4 6 8. Now count balance and trot again. So we count from here 2 4 6 8 10 12 14 16 18 20 22 24 26 28 30 32 34 36 38 40 42 44 46 48. So there are 48. Therefore no remainder. This is the Lewis structure for SF6.